Okay, in this first screencast covering the laws of motion, we'll be talking about inertia and mass. So first of all, inertia is the property. Okay, it's not a force, it's a property of matter. And it deals with the resistance of that particular object to changes in the state of motion. So it's the property of matter that resists changes in motion. Okay, not motion itself, but changes in motion. So if we're currently at rest, inertia will give us an idea of just how difficult it would be to make us start to move, to change our current state of motion. If we're currently in motion, inertia would tell us, or give us an idea of how hard it would be to make us stop moving or change from the speed that we're currently at. It is a property of matter, so the amount of inertia an object possesses is based solely on its mass. Now notice that's not the weight. Weight is a force, it's a gravitational interaction. Mass is the amount of matter your object is made up of. And mass would not change no matter where you were located as you moved around, unless you actually took away some matter from the object or added matter to the object. Your weight can vary based on your location. If you have two bricks and you want to figure out which one is more massive, one of the simplest tests is to apply equal forces and see which one changes its state of motion the most. So Shirley, she short here, is going to, she can't lift the bricks to figure out which one's the heavier one, or therefore the more massive one here on the face of the earth. But she's going to push the bricks. Now, the one with the larger change of motion, so the one that speeds up the most, the one that has the most obvious higher rate of acceleration, must have the least resistance to that change of motion, so it must have the least amount of inertia. Therefore, it must have the least amount of mass. Again, as she's doing this experiment on the Earth, then that would also be the least amount of weight, because the weight is directly proportional to the pull of gravity of the Earth. If we take her into space where she's far enough from any object that there's not a significant force of gravity, and we have her push and do this exact same experiment, it's going to result in exactly the same overall decision as to which one has more mass. Because again, the one that has the larger change of motion will have the least amount of inertia. Doesn't matter that there's no weight as one of the possible forces around. We're looking for the one, and it's a comparison between two objects. So we're again looking for the one with the larger change. There we are back with delta again of motion. Another way to think that is the larger acceleration is going to again have the least amount of inertia. And again, the least amount of inertia means the least amount of mass, because mass is the sole determiner of how much inertia an object has. If a moose were chasing you through the woods, it has a large mass. That's very dangerous if it should happen to hit you. But if you zigzagged, then we'd put its mass to a disadvantage. And the reason for that again is the large mass of the moose means it has large amounts of inertia. That means the moose is going to have a very difficult time changing its current motion. So if it's moving straight ahead chasing you, if you zig, it's going to be very hard for the moose to make that change of motion. You're going to be able to make a much brisker, quicker cut than the moose will, and so you probably will be able to avoid them if you make that move at a good time. If you're too far away, well, the moose will manage to compensate. If you're too close, it may be too late to make your zigzag move. But the large mass of the moose at that point would definitely be a disadvantage if it's trying to catch you. Now, inertia, again, can be described as, and we can wipe out A right away. It's not a force. It has nothing to do specifically with force. It is a property of matter. Willingness of an object to eventually lose its motion is not enough, and willingness is kind of a wishy-washy word there. We're not really talking about an object willfully choosing to decide to do anything. And again, it can't be C because it's not a force. It cannot possibly be a force. Okay, it's a property of matter. So the best answer is D. It's the tendency of an object to resist change and keep doing whatever it's currently doing. So if it's currently at rest, its inertia will keep it at rest. If it's currently moving in a straight line at constant speed, it will keep moving in a straight line at constant speed based on its inertia. To cause these changes in motion, we're going to need some kind of force situation to occur. If I'm trying to rank these four in number 7 here, the order of least amount of inertia on the left to the greatest amount of inertia on the right, all I have to do is look at the mass values. Okay. I do not have to look at the velocities in any way. The velocity has nothing to do with inertia. Okay. It's just the mass. So if we're looking at you want to look at the numbers and you want to put them in order of least amount of mass on the left to highest amount of mass on the right. 5 is our smallest, so that's going to be object C. 8's next, that's object D. A next at 10 kilograms, and then finally object B. So if one of these was moving in a straight line at a constant speed, the one that would be hardest to stop, hardest to turn, hardest to change its current state of motion would be object B. Okay, so heavier things with more mass, which are therefore heavier on the Earth, tend to be more difficult to get started, and they also tend to be more difficult to stop. So something like a large train with many cars can take a mile or more to stop because it has so much inertia. Whereas a small motorcycle can move and change its state of motion very quickly and can go from a very slow speed to a very high speed in a short period of time. Okay, so that's the property of matter that we call inertia. Again, it's based on the mass, and it is the tendency to resist changes of motion.